This is part 2 of our video, the Q&A section with Kiril Mugerman, CEO of Geomega. Geomega is a clean tech company developing and commercializing extraction and separation technology for the rare earth and critical metals to be used in recycling and minerals processing. We are doing our deep dive into the company and markets and answering questions from our audience. If you are interested in learning about new growth companies, please subscribe to this channel. And if you find this interview informative and helpful, please press like. It really helps with the algorithms. Let's start at the core of this is the technology. Without getting into a chemistry lesson on obviously what you can share to the world, but you've got a platform technology, and then you're off of this core platform, you're finding these different uses. Or without getting too technical, can you just give a bit of an overview of kind of what your technology is?
It's a mixture. You can refer to it as a platform, but at the same time, it's just the way we think. So I've been now working with Puya since 2014, and so the way he approaches the problems is very interesting. So the approach is always recyclability of the assets of the reagents. So that's one thing. Quite often, that recyclability is very similar between one project and another. So to that, you can refer as a platform. But quite often, like in the case of bauxite residues, yes, there is iron there. And in the rare earth recycling opportunity that we are working on, there is iron there. In both of them, you're looking at iron at 50% plus. So there are some similarities in terms of how we attack the iron and how we work with the iron. But at the same time, in magnet recycling, there is no sodium, there is no aluminum, there is no, those other components are not there. So you cannot say that it's the same technology. You have to start it from scratch, but with the same blocks already that you've developed, and then you start connecting those blocks. So the idea is we have a team that has grown over the last 5 years, and by us working on many different projects, it actually gives us a huge opportunity, because the more you look at different projects and you solve a problem here and you solve a problem there, sometimes that connectivity in between the two projects or between working with those two different materials is the solution for the third one that maybe was before that was non-solvable. It doesn't mean that our technology works on every single material. We receive some material and it just doesn't work, or sometimes it requires too many modifications, or we just cannot purify it or extract it to a certain level that is required. So it's a combination of between going to the basics of what we already established and developed, and putting together some new thinking. And as I said, it's all a question of approaching the problem, and the way my colleague Puya approaches that problem, that's for me is the most exciting thing, because you approach it with a very different angle. We like being different, we like thinking outside of the box, and that helps us a lot.
Are there any, you talk about your reagents, and are there special reagents or special sort of equipment that you need, or is it basically just you've got a different recipe and a different flow chart than other people? So there's no sort of special widget in there that allows it. It's just your approach to it and just using the common technologies in a different manner?
I would say yes. So so we don't develop our special chemicals. Some companies in rare earth processing, they develop their own ligands. They have to synthesize them from something else. We don't do that. So we really use, we go after materials that are available, chemicals that are available. We quite often look at chemicals from other industries which are not traditionally used in mining, to see if there are synergies that we can benefit from. So by looking at other by looking at other industries where it's being used, you can adapt as well the equipment. So when I say equipment, and we mentioned that in the presentation, we try and avoid reagents which are, one, very hard to recycle, or very bad to the environment, or we try to avoid reagents which the equipment that once you are going to be using them. So in a chemical plant, for example, some reagents you just are extremely corrosive, and then you require very expensive reactors, vessels with special coatings that will cost a lot of money. in order to just operate in them. So all those things we are trying to reduce, we are always trying to remove that from the equation as fast as possible. Because if we are stuck with something that is going to be extremely capex intensive, extremely hard to operate, or will result in a lot of effluent, we want to move away from that route, or we want to move away from that material.
All right. And are you doing your IP strategy? Are you doing patents, or obviously when you do a patent, then the whole world gets to know about what you're patenting? Or are you trying to it's a whole bunch of steps and processes and keeping that as your internal intellectual property?
Okay, that's a good question. It depends from one material to another, and I'll tell you why. When in the case of rare earth recycling with magnets, until now we stayed away from patenting it. We did patent the technology for Montviel. In the case of Montviel, you don't expect necessarily a Chinese company to go and use that same technology because it would not necessarily be as applicable to them. But in the case of rare earth recycling from magnets, yes, you can expect that, as you said, once the patent is out there, everybody can use it. And in some countries, without pointing fingers here, it's going to be hard to enforce those patents. So that's one. But then suddenly you start working with some other materials. Sometimes those materials don't even belong to you. So in the case of bauxite residues, we don't own the bauxite residues. There are 20, 30 alumina companies that own those bauxite residues. So when you actually work with those other companies and you want to work through a licensing technology, or through licensing the technology, or through royalties, patenting is actually encouraged. You do need patents, and that's not only one. That's only one thing, but as well, you need to look at it the way you want to patent. If you want to license something, you want to license something that you can actually protect. Because if you're licensing and you cannot protect it after that, then the value of your license is zero. So there are different ways of looking at it depending on what is the material, who is the competition. Well, if the competition is a bunch of different major companies, it's much easier to work with them and to collaborate with them, sign agreements with them, than when you're dealing with just one country, when all the demand is just in that one country and you're afraid of operating within that country. So it's always an analysis depending on the material, depending on the potential partner, if you are going with a patented technology or protected in-house technology.
All right. Going to the recycling, the magnet recycling side of it, you're opening with the St. Bruno facility. Like you can't give timing or anything, but what are the milestones we should be kind of expecting? What, like, and you don't have to tell us when we should be, but what are the things that we should be expecting to come, like, appear in a news release in the coming months or years?
Okay. So yeah, no, you're absolutely right. We won't be giving any timeline specifically here. That will come out through our press releases, official communication. But for sure, we are finishing up and advancing very well on all the detailed engineering. And engineering never really ends. Engineering goes all the way until the end, until the construction is done, and even then, there's always engineering. So we are advancing through the steps to the point where we'll get to all the equipment finalized, designed, ordered. So we'll be announcing progress on where we within the several aspects of the detailed engineering. What can we order? When are we ordering? So we'll provide information on procurement, on the procurement process. The building, the facility is secured, and we are ready to start bringing in the equipment and start putting it together. So we are talking to all the steelworks contractors, the construction companies that will be the ones putting it all together. So all those little things are advancing, and it's many different moving parts. For sure, it's first time, it's a brand new technology, so there's nobody that you can just take the drawings off the shelf and say, okay, here. So everything is validated, put together, and modified in order to provide final specs for the equipment. Though that equipment then comes to a point where we can start ordering it And once the equipment is ready, it arrives, then we'll be able to start putting it together. And as we are putting it together, some of the equipment will start getting tested. We'll be able to start small scale productions here and there, depending on what equipment is being tested, parts of their process being tested individually until the full plant is up and running. So it's not a question of years, that I can assure you, but we'll be providing information on that in the near future.
All right. With that St. Bruno facility and the magnet recycling, your feedstock, the magnets you need to process. I guess I have two questions. Like, how difficult is it going to be for you to find sort of feedstock for you to process based in Quebec? If you were in Japan or Korea, you'd probably be a lot closer to it there. And is there, with the technology, I don't know how, like, is your system very sensitive in case like some other metals or stuff get thrown into that? Like, from one truckload of feedstock to the next, if it changes a lot, could that screw up your system? And sorry, I kind of threw two big questions at you there.
No worries. So the first question was on the supply. Supply is very interesting in this industry. So there's a lot of that supply that many people are not even aware of, and it just accumulates and gets lost. So that the more you are talking about to companies at conferences, recycling industry, you find that many people are there to actually offer you this material. And often it is in small batches, and there are groups that will be centralizing it, recycling companies that will be centralizing it, and once they have larger volumes, they'll be shipping it to us. So those that we are mostly talking about end of life. So end of life is growing and can only grow once there is an operating plant. The recycling industry functions through the same principle that it's been operating for the last hundreds of years. There is a scrapyard. They buy material. If there is value in them, they sort it, they separate it, and then they ship it off to the next company that already will pay them more because it's now separated. And more we talk to recycling companies, to those scrapyard companies. They all go and recycle electric motors, and they all work with quite a few different applications where magnets are present. And we are identifying the steps where the magnets are located or get trapped. And that magnet, they want to separate it and they want to sell it to us, because if they sell it to us, they get paid much more than if they sell it to a steel refinery, who will pay them as if it's just iron. So for them, it's much more advantageous to do it to sell it to us. And because those plants do not exist today, a lot of those scrapyard companies just don't know that they have this opportunity. So that's secondary feed. Primary feed in terms of recycling, you're absolutely right. It's the manufacturers. So we do want to see more manufacturing open up in Europe, in the US, and just in general outside of China, because more and more production and all those companies, when somebody is looking, companies that are putting together their first plant for magnet, they always ask the question, who is going to be taking off the 15, 20, 30% of waste that they produce? So that waste is very important for them to get value for it, because they cannot just dispose of it and lose it. So shipping that material is actually not that complicated, because it's very dense, and because it's dense, one container, full 20 tons, and the volume and the grades that we are dealing with, we don't have to ship hundreds of containers. So it's really positive in terms of the logistics. A lot of those things are already very well established, and we are regularly talking and working with magnet manufacturers, receiving materials from them. And one of the questions that we are addressing is, okay, well, the material from this company arrives with those impurities, for example. How are those impurities affecting us? So we do run batch scale, either bench test or a pilot test, using our pilot facility that we have in Boucherville, and we test what can we do with it, and do we require to make any modifications, or are we okay as is? So all those things are usually addressed, and those are part of the research team is always dedicated to testing various streams, and there are e-waste companies that come up with streams with magnets that they want to get value for. So all those streams, depending what are the impurities we want to analyze, and the e-waste industry is actually very different because there are some different impurities or different assemblies. So we have to test it all. We have no choice. But that's part of operating this type of business. And it's totally normal. In the mining industry, it's the same thing. Sometimes your ore is different, so you have to adjust. So if the adjustment is too strong, obviously we will not be able to either buy that material or we'll have to pay much less for it because of the impurities in there. So all those opportunities are being addressed on a regular basis as more and more companies reach out to us and offer us material.
So I'm guessing the end of life material will be more complex because you don't know what's necessary. Like there are magnets from here and they're all collected. But when you use the scrap, the waste product of a manufacturer, from that you'd have a much more consistent kind of feedstock coming through.
Correct. It's much more consistent from a manufacturer, but at the same time, in the case of magnets, end-of-life magnets, if they go to a scrapyard, and again, this is not manual business. Yes, in Asia there are sorting factories where people sit there and separate the metallic, non-metallic, plastic, and this, that. Here, everything is done in big factories. Lots of sorters, automatic sorters. So they separate all your aluminum, they separate your plastic, the copper out. So you end up, the worst thing that you can end up with, I would say, is some increases in copper, for example, here and there, but really a contamination in steel. So instead of just being 70% iron and 30% magnets, you can end up having modules with more steel assemblies, and those steel assemblies will dilute your magnet. Instead of being 30%, you might be dealing with 5 or 10% rare earth element content. So so those things tend to change, and that's being, as I said, addressed on a regular basis, because before we commit to any material, we always want to either understand how homogeneous it is, how continuous that stream is, and any of those variabilities obviously will influence the pricing and will influence as well us being interested in taking that material or not.
Are you very concerned about getting sufficient feedstock A to run it at the pilot plant at the the $10 million a year facility, and then what it would take to get it up to adding the additional shifts and all that?
So for the demo plan, the first shift, we are full. All the groups that we've spoken with and LOIs that we signed, those that are already operational and are ready to send us the material, we have enough for the one shift. If we are to look at second shift and third shift, I would say today I would not be able to fill all the 3 shifts. The third shift we will need probably, or we will want to see a US manufacturer. And there was an LOI with a US company that is recently just announced fully financed to put their magnet facility into production. So as we're seeing more and more of those facilities open up, that would fill up that third shift. But of course, if we really succeed in securing a few extra supply deals from Asia, the second and the third shift can be filled up very, very easily.
And is that the Everwin Magnetics company you were referring to?
No, I was referring to USA Rares, the one in the US.
Gotcha. And you announced that Everwin, is their facility getting built and set up, and is that
all those
going
groups, they are putting financings together, plans for starting different scales of different plants in different jurisdictions with different partnerships. So we are seeing much more interest, more and more groups. I would say there is at least 4 or 5 groups right now in North America that are trying to put magnet plants together of various scales. So we are talking to all of them, and the first one to go into production, the second one will take the waste material from them.
All right. Okay. So on the business model, it makes like a ton of sense to have the St. Bruno facility to show that you're doing it. But as you want to scale up, and you mentioned being you don't want to be a big CapEx company. So the next steps, and I probably haven't gone too far down this, but would it be like licensing out or doing a joint venture in Korea or Japan or Europe or in the south of the US, or I don't know, wherever? Would it be more on that kind of a structure, or would you open up inward Asia and then set up your own facilities there?
Both things are on the table. I would say that will all depend. There's a lot of those mega manufacturers. The rare earth industry by itself is very, full of skepticism. So a lot of those mega manufacturers, they want to see it work. They want to see the demonstration plant work. And then from there, you can really sit down and figure out what is the next step. Do you go and build a plant within the plant of some other mega manufacturers just to do recycling? So you build it specifically to their scale, or do you put a central facility somewhere in Asia or in Japan or in Europe? All those things are possible. If you're operating directly within their facility, sometimes it's easier to go through a license rather than going through building it yourself and operating it. And obviously, there's a lot of complexity with starting 5 facilities all over the world. It adds cost to the operation. So there are different things that are being evaluated. It all depends on the size of the partner, which company first we will sign an agreement with in terms of the major magnet manufacturers. They all have different ideas and they all have various opportunities to consider. But the first question is the demo plant running? Because nobody in the rare earth industries believes anything until they see it actually run.
For sure, that makes total sense. They want that nobody's going to put up that capital and risk their supply chain until they know it's working.
Correct.
I'd like to switch over to the Montviel project right now, and just how is that going to progress? And then part of that is dependent upon your technology for the separation. Is that sort of, I wouldn't think you're going to ship stuff to St. Bruno. Can you just talk about how that project gets developed alongside with, because it's very technology dependent, I'm presuming. So how does that step forward?
So Montviel is a very interesting project. It's let's just say it's a simple bastnasite, right? There are no unknown minerals there so basically there are traditional methods to process it. The problem with traditional methods is always a question of, well, it's not environmental enough. So our technologies that we've put together are able to put Montviel on the map as a clean rare earth project, but obviously we still have some work to do on that. We stopped main work on Montviel in 2015. Since then it's been dormant with some work progressively advancing on the side. But Montviel has a really good, interesting opportunity because it's beside the rare earths, it has niobium and it has iron. And iron for us became such a key driver in all our technologies, whether it's in the bauxite residues, within the magnets, or in Montviel. In Montviel, iron content is approximately 25%. So that generates an interesting additional revenue that it's not 43101 yet, so I won't necessarily specify those numbers just to stay within the regulations. But Montviel has a really good opportunity to become a project that, because it's, let's say it's in the just in the north, just at the tip of the central Quebec, it's still within the traditional infrastructure, roads, power, and communities, so labor force. So Montviel most likely will keep advancing it to the point where we can put together the more updated finalized flow sheet, which integrates the work from 2015 and the rare earth recycling work and the bauxite work that goes together, and then we can put it into a pilot and demonstrate to the Quebec and the Canadian government that a very large project can be developed in such a way without having all those negative environmental aspects to it. Once it's in production, of course, Montviel, and whether it's Geomega or through a partnership with another company, Montviel will produce a concentrate, and that concentrate will have to be produced locally. That rare earth concentrate will have to be separated then, and that separation can either be done by Geomega in a different facility, or, and most likely how all financial models 43101s will be presented to be comparable, we'll always have to still assume okay, what happens if we ship this concentrate to China? Because you really want to always compare apples to apples. All the other projects are always looking at shipping it to China. You want to see what will happen there, and then what will happen separately if you were to separate it locally. So Montviel is slowly becoming more and more present in our labs. We are doing some work to advance it to a point where we can actually tell the market, okay, here's what Montviel today is based on today's rare earths pricing, and what it could be if rare earths do actually move up, keep moving up based on the demand of coming from the electric vehicle industry and the renewable energy industry. So Montviel is very positive. We really love that project. It's got a bastnasite, so it's a much simpler mineralization, as I mentioned by accident, the word monazite. It has no monazite really. It has some, but most of the mineralization is within the bastnasite, which is the whole advantage that we have there. So Montviel will, so for example, the difference between Inord and Geomega, Montviel will be developed within Geomega if ever it gets developed by Geomega or a partnership between Geomega and another company. Inord is the group where we are doing all the technologies development, but Geomega is the actual development group.
All right. And is there a lot of work you need to do on the actual property itself, or you're comfortable with how the resource is defined and all that, and it's really the technical processing side of it that where the work needs to get done?
I would not. There is no need for any drilling on Montviel at all for a very long time. Not until you complete a full pilot and a preliminary economic assessment study, 43101. You don't need to do any additional drilling, I would say. Only then to bring it to a full feasibility study that you would need probably some additional infilling drilling in some areas or some geotechnical drilling for the stability, for the design of the underground ramps, for the stability of the ground. But right now, there is no drilling that's required for Montviel.
And to get through the feasibility study, you'd have to get your mineral processing technology to a point where you can say, hey, in our engineering, we have these kind of economics, and you've mapped it out well enough where you have a high level of confidence then to have that, and then version 2 of shipping it off to Asia, the concentrate, right?
Absolutely, yeah.
All right. Okay. Let's switching over quickly to the bauxite side of things. You talked. Obviously, you didn't name your partner in the news release, and I'm presuming you're not allowed to talk about who your partner is. But you talked about a research partnership. Can you just flush out what exactly does a research partnership mean without putting you offside into whatever legal contracts you're in?
The collaboration, the research partnership is really to bring it to the piloting stage. It's collaboration through technical expertise from their side to fully understand the final streams that will be coming out from our process. One of the advantages is we are not trying to purify every single component within bauxite residues. We are only trying to bring them into sellable concentrates, and those sellable concentrates to those major companies can represent something. So they have that expertise in terms of to what level you have to bring every concentrate so you can sell it and make enough money from it, instead of having to purify every single one of them down to the final 99.9 purity of whether it is titanium or vanadium or whatever are those purities. What can you combine, what you cannot combine? They have all this knowledge, because if you are trying to separate everything in bauxite, in your bauxite residue plant, you obviously have to add more and more capex. What we are trying to do is provide a certain amount of streams, and we are working with them to characterize those streams. And as we are characterizing those streams, is putting together the test work to validate some of those aspects, some of the questions that do come up. And then, of course, we have the opportunity to really bring to do the next level of economic assessment, confirm all the numbers. And once that research collaboration is done, is really where we'll say, okay, now it's ready to go to a pilot study.
All right. And you mentioned, I don't know if you mentioned it verbally or if it's in the news release, where there'd be 80-20, you'd be able to process 80% of it, if I'm correct. So that means like if there was 1,000 tons of this, 800 of the tons you'd be able to process, clean up, and ship out, and they'd only be left with 200 tons of.
Correct. Yes, as final, as sellable products, and that's the main objective. So yeah, we put in the press release, and it's in the presentation. The 80% is very important because currently 5% of bauxite residues can be used, and there are several other technologies that if you run them at whatever is their full scale, let's say you'll use up 20 or 30% of the bauxite residues, and those 20-30% do give you some value, but you still have to deal with the remaining. And the idea in bauxite residues in the aluminum industry is to really reduce significantly that residue. That residue is an amazing byproduct if you can treat it as is, because otherwise it's just sitting there and it's an environmental footprint that nobody wants to have. So the alumina industry is very proactive in trying to come up with a solution to use it up more. And we've seen, and obviously as we researched over the last year and a half this subject, they've improved in storage. So they shrunk the footprint by storing it more compactly and improving all those material handling aspects, but it's still there. So the idea is the more material, the more of the iron you can take out, the more of the alumina you can take out, the better it is. And then for us, with our technology, we can remove the iron, we get the value for the iron, which is already basically a very big component and is covering a good portion of that OPEX. Of course, alumina, we are dealing with it in the alumina industry, so you have an automatic buyer of that alumina. And then next thing is rare earths and scandium. And if you are able to, because everybody's been always trying to get to scandium, and we know it's possible and we can get to scandium as well, just like everybody else. But going after scandium alone does not solve the problem. You're basically displacing issues, displacing the problem if you're only dealing with the scandium. So we're really trying to attack all the aspects of cleaning it up. That's one, and then once you clean it up, make your money from the rest of the metals.
All right. And is there any risk that through your process, what's remaining will be more toxic, like a smaller pile of toxic stuff, or it's just generally going to be less waste, more environmentally friendly, and some economic value to boot?
Well, for sure, one of the work is always on characterizing the streams, characterizing the remaining waste, what form it is it solid, is it liquid, can it be neutralized and easily disposed of in a different facility, can you ship it away even? So all those things are to be addressed because you are dealing with a huge global challenge. And in some of those cases, in some of the locations, the answer would be different. In some places, maybe you can just store it locally, and in some cases you won't. But part of the test work is to always to characterize, but definitely the objective is to always not having a waste that is more toxic or more complicated than it is already. So for us, going after specific streams, 80, our target is to go higher than that, but obviously and in bench scale in the lab, we were able to get significantly higher than 80, but it's all up to follow-up work and test work and then pilot work to demonstrate how high can we get. Can we get to 90 or 95, or do we stop at 80? Is the final recoverable sellable is maybe going to be less than that? So all those numbers are to be validated, but once you start playing with the actual revenues potential, if you can do it in the right way, the market is there, the opportunity is there, and the environment is there for it. All those major companies are looking for ESG type opportunities to clean up and to improve, to show to their shareholders how they're trying to change.
All right. I'm just going to ask one last question, then we'll get to a bunch of questions that are popping up there. At the beginning of your presentation, you talked about more items you hope to appear on the page where your different projects are. Am I maybe, and obviously you're working on that, but that would be maybe you figure out a process or a flow to work on gold mining tailings, or I don't know what, but just, is that what you're talking about? Other opportunities in other industries or sort of leftovers you can clean up?
We look at we look at some tailings opportunities, whether they're gold or whatever it is, we don't really care. as long as the value is there and as long as the right components are there. So is there a lot of iron? We love that. If it's really not iron driven, then we cannot really help. We don't have a magic solution that works on everything. Is it a question of we need to get to a specific metal, but we need to figure out a way how to recycle those acids, those reagents, and great, we can help. Or if the only way to get to those metals is a different chemical, some acids that are non-recyclable or extremely difficult to recycle, we stay away from that too. Some industrial waste, so bauxite residue is an industrial waste. So other industrial residues we started looking at, and those are quite interesting. But in some of them, you have the iron, but you just don't have the other metals. So there is a big trade-off, and in some situations, we are trying to see if there is something to be done, or it's only just the cost of the environmental cleanup, because there's just not enough value to generate out of that. And again, the decision is not ours. The decision is the company that owns that waste, right? We only are there to say, okay, here's the best solution, what we can do. And if that's not good enough, well, it is what it is. So we always try and go and attack a problem. And quite often it's always going to be connected to those rare earths. If there's rare earths in there, whether it's primary mining or secondary sources, we are interested in looking at, and we're looking at a few iron-rich materials, either primary ore or secondary sources, and then industrial sources with problems.
All right, there are a ton of opportunities out there. Like, you've got an association with NRC, National Research Council. How big is your team, and are you associated with any universities in Quebec or anywhere that kind of get some leverage off of someone else's brain power?
Our team right now, the research team, is 10 people, and we are talking and partially working with some universities. No, we do have a couple of small collaborations with several groups where we are working, where they are solving a part of the problem independently, but most of the work is all done in-house. I think I forgot the other part of your question.
I know, it was just, which partnerships you have and how many people do you have, technical guys do you have on staff?
So it's a small team. We are within the NRC, but we are separate from the NRC. There is a lot of research done within several NRC groups, and some of them is actually with magnets and rare earths and all that. But that's independent from what we are doing. But quite a few different Quebec institutions are working on rare earths, and we're always talking at several of the conferences and looking at opportunities to collaborate always in the future. So no, there are always, we are looking for synergies always.
All right, I'm going to go straight to the Q&A questions here. Thanks for hanging on, everyone. The first question is why would an investor choose Geomega over other rare earth projects in Canada? And I think that's kind of interesting because it's a huge question, but you've got two parts. You've got your asset, your on the ground Montviel Project, and then you've got all this technology stuff. So there's some other technology companies out there, and there are other mining or resource companies out there, and you're a bit of both. So
I don't. Okay, so that's an interesting one. When I used to be an analyst, it was easier to answer, but having the hat of a CEO is a bit harder. Look, for me, the advantage of I can only talk about our advantages, and if we are looking at the Montviel case, we have the largest project. It's all focused on neodymium, praseodymium, which is the main ingredient, which are the main ingredients of the magnets. But really, it's all the infrastructure that comes with it, the ability to extract it and develop that technology in-house without having to go to all those external groups that potentially could or could not develop their solutions for you. So we don't have that. We are not dependent on those external groups. Of course, having an opportunity to invest in a rare earth company with a cash flow coming in from rare earth recycling and using that cash flow to build up the portfolio of other rare earth materials coming into production, including Montviel, it's a huge plus for an investor who wants to have a position in a rare earth company. And of course, being able to do that while saying that it's as well a clean tech company that's helping to clean up other industrial or mining waste opportunities, that's huge, because scandium is part of the rare earth group, or it's together with yttrium, and scandium is a huge market, and one of the best ways of getting into it is through industrial waste recycling, basically. So it's having the diversification. Sometimes people say in their portfolio they need to have a diversity, so they cannot just have all the companies in their portfolio being gold. So they need to diversify. By being able to invest in Geomega, you have an opportunity to invest both in primary rare earth mining, secondary rare earth mining through recycling, and technologies, with an opportunity of investing here into a royalties company. We do want to have in the future, as we develop our technologies, to offer this royalties opportunity and licensing, because this is direct cash to the company with very little exposure to extra capex. And we've seen this in the gold and in the traditional mining industry. The royalty companies, if they're well built, if they're well structured, yes, it takes years to develop, but if it's really well done, those companies become gold mines.
Yeah. Because you've got enough capital on your books to build your pilot plant, and that could start generating cash flow. So I'm not going to try to pin you down. Are you ever going to raise capital again? But you're going to be generating cash flow that can help sustain your growth opportunities and so forth. So that will hopefully mitigate some risk of additional dilution for the company.
Absolutely. So yes, we are well funded right now for all the activities that we need. Plus, we have an additional amount of cash potential in warrants in the money. So I think from that point of view, we are in a very good situation right now, and not looking to do any financings. I'm not the first CEO to say it and then suddenly do a financing. So I understand the sensitivity of that question, but no, in general, we are not looking to do any financings. We are well funded. We have the support of the Quebec government as well. And as soon as we hit cash flow, so many other doors and opportunities open.
Is there any opportunity for M&A? For you seeing some technology or another project or anything? Have you kicked that tire at all?
Absolutely. There have been opportunities of M&A, companies asking companies want to understand what are we doing with technologies, and especially bauxite residues is a huge sector. So companies are asking questions all the time. And through us developing technology for somebody solving a problem for them, of course, it always means potential M&A opportunities. But the company is very well positioned to grow internally. As you said, the cash flow can come and keep growing that R&D section, while growing the potential revenues from whether it's a second or a third plant in rare earth recycling or in partnerships with some other groups.
All right. A question here is, what is the operating cost per ton versus value of metal recovered? That you were, I think on that slide, it's a 20% sort of operating margin you talked about.
In rare earth recycling, yes, we are targeting a profit margin of around 20%.
All right. And then on the bauxite stuff, that's just way too early to talk about that, I'm guessing.
Look, we have preliminary internal numbers, so a preliminary economic assessment, but an internal one just to demonstrate the potential, and of course to bring in a large partner like we've done here. You do need those numbers. So those numbers are very positive and look very good, and that's why somebody wanted to work with us.
Gotcha. There's a question here, I don't quite understand it. Maybe you do. How does your technology differ from that of Urban Mining Company? I don't know who it's capitalized Urban Mining, so I guess that's the name of the company.
As you were saying Urban Mining, I was thinking of another company you were going to say, but no. So Urban Mining is a private company in the US that is focused on developing from what we understand, it's magnet to magnet recycling. So you take an old magnet and you do some process and you produce another magnet. So you don't go through chemistry and reduction down to the oxide again. We go down to the oxide. So I'm not that familiar with magnet to magnet recycling. So from what we understand, that is what urban mining is working on based on their presentations. Magnet to magnet recycling, what we know about it is from what we learned from visiting China and operations there and talking to other companies in Europe. So magnet to magnet recycling does exist and does happen. If their technology is an improvement on that, I'm not familiar or I don't know. But one of the key advantages of what we know, again, comparing to what's standard in China, is chemical recycling, going down to the oxides. Your oxide from my plant and oxide from a mine are the same. You won't know the difference. So when you make a magnet from either of them, it would be the exact same magnet. The only thing is with this one, if you isolate the one from our plant, you'll be able to say, well, that magnet is made from recycled oxide, recycled magnets. But you won't actually see the difference in the magnets. If you do magnet to magnet recycling, so you take magnet and you do a conversion and you make another magnet, the situation in China is that that new magnet, so the recycled magnet, will be a lower quality than the previous magnet. I don't know, I cannot comment about urban mining if that's the case or no. I'm just, again, the Chinese situation. So there's a reduction in the quality of the magnet when you go magnet to magnet. So it's solid to solid. So many companies, some major companies that we were talking to, magnet manufacturers, they were always making sure, okay, but you're not going to be producing that powder that will make a new magnet, because we don't want to have that reduction of quality. So no, when we go down to the oxide, and again, there are some opportunities that open up when you're dealing with the oxide and chemical recycling. You are less prone to variations from other impurities or impure material, basically, or poor quality material. So those materials cannot go to magnet recycling in China. But again, I cannot comment much on urban mining.
And magnet to magnet, just really crudely and incorrectly, I'm sure, you kind of melt down the old magnet and put it into a new shape of it, or more than that, but basically you're just taking the old one and reforming it, as opposed to bringing it down to a raw material and then baking a new cake with that.
It's a pyro method. It's a crushing, grinding, and special treatment, and you make a new magnetic powder, and then that powder goes to the blast furnace as if it was a primary magnetic powder. So yeah, it's a bit of a different process.
All right. I don't know what to do with it. What is the situation about hydrogen? That's the question.
So hydrogen is interesting. Yeah, we mentioned hydrogen in our press release in January. We were able to isolate hydrogen, nice, clean hydrogen stream. And so we wanted to see how hydrogen can get involved in other opportunities that we are working in. In the case of magnet recycling, we calculated the volume of the potential hydrogen, and it's not enough to actually collect it, store it, and sell it. One opportunity in hydrogen there is to actually reuse it internally as a heat source instead of using, let's say, natural gas to heat up the reaction to the temperature that we work in. So hydrogen we definitely know that using our technology, we can isolate hydrogen and make it into a final product. So now, as we are looking at other streams, we are always evaluating hydrogen as an opportunity for our technology. So that's within one of the streams, within one of the R&D projects that we are working on. Hydrogen is an important component.
All right. There's a question here about companies developing magnet-free electric motors, which I didn't think was possible, but and if that does become big, will that affect rare earth oxides?
Yeah, so I like reading those articles. It's interesting. Some of them are startup companies, fairly advanced. Others are less advanced, and some of it is pure research. I think Toyota has been really big on figuring out how to make rare earth magnets, permanent electric motors without rare earth magnets. So definitely the movement is in this direction, and that's why, in my opinion, rare earth pricing cannot go through the roof like it did 10 years ago. And the situation with, I guess that brings us back to Montviel and investing in Geomega versus any other projects. A lot of the other mining projects where they're only dependent on rare earths and more or less using traditional technologies, they have no choice, but they need much higher rare earth pricing, as you can look through all their 43101 data, and they need much higher rare earth pricing to be economical, to be justifiable to finance. But the pricing that they use for neodymium and praseodymium and some of the other rare earths is too high for the industry. So if you take the price from whatever, it's $80, I believe right now, neodymium and praseodymium, if you take the rare earth pricing from $80 to $250, which is between $200 plus is what the industry wants to see, the rare earth juniors wants to see, that at that price, yes, Toyota and everybody else will probably be trying to figure out a way how to put an electric vehicle on the road without any rare earth magnets in there. But at the current price of $80, $60, $100, even $120, there is no need for that. So my rule of thumb is $100 up. Sorry, not $100 up. A doubling of the rare earth price is a 10% decrease in rare earth consumption, just because the industry engineers it out and comes up with all those creative ideas how to do something that before was not feasible.
Yeah, and then you're part of that. You're putting a cap if everything works out as planned. You'll be putting a cap on or reducing the potential price of rare earths as you can you can develop new projects as well as recycle old ones in an economical way. Another question here to clarify: if REE, rare earths, in bauxite waste is $80, what does it cost to extract?
Sorry, I'm a little bit confused. If rare earth elements are $80,
I guess they're asking what is the cost to extraction, which you're saying there's good margins in your preliminary stuff, but you're not coming out with any official numbers, I guess.
If the presentation that I showed and that slide deck will be on our website later, today or tomorrow, but I'm just looking here, and rare earth elements and scandium are 25% of the value, so not 80.
Well, $80, it's saying. What if
no, the $80 is let's say if the total value of a ton is around $100, so in the press release we put between $80 and $120, so just rounding it up, taking the middle here, 100, and we are recovering 80% of the value of the volume, and that 80% of the volume is iron, aluminum, and let's say rare earths. So not only rare earths make this $80. It's a combination of those metals.
Gotcha. If we didn't answer that question clearly, email Kiril or myself, and I'll forward it over to Kiril, and we can get that addressed.
But in general, we cannot comment today yet on the operating costs. It's only an internal model that we have not published. But the way, just to give you the person who asked that question an idea, definitely the way we look at it, just recovering iron and potentially aluminum or part of the aluminum, that should probably be covering a good portion of your operating costs, and then all your critical metals become your extra value. Because if you look at some other technologies that have been developed over the last 10-15 years, they do the opposite. They go straight after the critical metals. They'll go after your scandium and rare earths, but that just by itself is not enough. So if you do reverse, just going after the critical metals is not enough to cover your OPEX, or just barely enough. So the project is not feasible. So instead, you actually need to kind of double at least your revenue from your OPEX here.
All right. And just one final question here. I think we've kind of addressed it, but I'll ask it. The Montviel project has not been in focus for 5 years. Is Geomega losing itself in diversification?
Yeah, well, for sure, some people ask that question. Montviel is an important aspect and it's a core part of our business. But if you look at the industry and where things have been going down traditional, the traditional route of traditional metallurgy, large mines, large environmental footprints, the OPEX is too high, and financing those hundreds of millions of dollars projects is very, very difficult. And I think in the last 5 years, since we took the decision of putting Montviel on the side while we are scaling up our technology, demonstrating that our technology can be viable, we haven't seen any of the other North American rare earth projects to really move anywhere, and even the Australian ones. So the only projects that moved are the projects that were in production in the US, Mountain Pass, or the Linus project that started production around 7 years ago or something like that. So other juniors, none of the projects are really moving anywhere, and I think we are doing the right decision, giving ourselves that diversification of looking at other materials, but as long as we remain within the core business of ours, which is rare earths, iron, and acid recyclability. If we stay within those three aspects, I think we'll be able to demonstrate a lot of value in the future, both through rare earth recycling, bauxite residues, Montviel, and whatever other opportunities might come out that are actually very economic. So I think diversification is good here. Working on multiple projects is a huge opportunity for our research team because, as I said, you learn by combining solutions from one material with another material. You actually gain a lot of pieces of the puzzle to work with to solve the entire puzzle. So I think from the path that we chose 5 years ago of clean technologies, processing technologies, that diversification is actually going to bring a lot of value to the shareholders.
All right, we're an hour and 20 minutes into this, so we should be wrapping this up here. That was really good. That was actually how your last comments there, I think, sort of summarized stuff quite well. But just to wrap it up here, any final comments you'd like to make?
No, rare earth recycling is advancing well. The market will be updating the market on this. Bauxite residues is a brand new thing for us, for the market. So we are there educating and explaining to people what it is. But we've been working on bauxite residues now for well over a year. We love working with major companies. They have big environmental problems, and we are there to help. And in the current market environment, those environmental solutions are going to be the way up.
All right, Kiril, thank you very much for taking the time to talk to us today. That was very informative. Have a great day, and we'll talk again soon. Thanks.
Thank you, Martin.